Hello, everybody. It's James here. Welcome you to our first live stream, and I hope you're going to enjoy this. I just want to say to you, I apologize. I've been away for some time. Just checking here. Could you let me know if everything is working fine? If you can see me okay? Because I can see my picture here seems not to be my picture. Let me check some of the messages here. Yeah, my picture is slow to catch up. So let me see if I can get someone to help me here. Just bear with me. Right. So here is, I'm told that everything is working fine. All right. So what I'm going to do is, you come and get this one done for me, please. Okay. So I just want to talk about electrical faults today. I want to talk about electrical faults. I'm sorry, guys. Let me just get sorted here. I'm not happy about a few things. Few things. So, okay, so we have a multimeter here. We have our electrical board here from our friends here, electronics. And that's what I'm going to use to demonstrate what I'm going to be showing today. As I promised last week when we were on our Zoom platform with Cliff, I said that I wanted to talk about, open circuit, high resistance. Maybe if we get time, I can also talk about the short circuit as well. I said to you, if you remember, if I can recap on what I said to those who were on the platform last week, I said to you, all the faults that we are going to find, that we are going to come across as long as we are technicians or diagnosticians, whatever you want to call yourself, all the faults that we are going to find, they'll fall into these three categories, okay? They'll fall into these three categories. You've got an open circuit, you've got a short circuit, and then you've got high resistance. These are the issues that you are going to come across. So I want then to try, and I know that many of you here will be knowledgeable, for the sake of some of my friends who have actually been talking to me in the background saying, look, could you go back and talk about electrics? We want to know how to read wiring diagrams. We want to know how to diagnose circuits. So I know we don't have a car. There will be a time when I'll be diagnosing these things live on the vehicle, and I've got a few vehicles that are lined up for that. But for the meantime, I just want to demonstrate using this board here. I hope we are not going to be long. I'll leave you to, if you have got a question, then you send me a question. If I can answer the question, I'll answer it right away. Forgive me, I don't know everything, okay? I do not know everything, but whatever I know, I'll share with you. If it's something that I can't answer, it's something that I need to go back and research. I'll go back, allow me to go back and research rather than to bluff you. I'm not here for that. I just want to share the little knowledge. I'm not an expert either, but I've been in the field. I've fixed cars. I've fixed problems. It wasn't easy from the start, gentlemen, ladies as well. It was not easy from the start. I used to, ring friends and ask, what do I do here? What do I do here? Which I'm really, really grateful. I'm so grateful to anyone, everybody who taught me something. Anybody who contributed to where I am right now. I can actually name names here, but let me not name names in case I forget someone, and then they will not be happy with me. So we have here our battery, and then we have that's the power coming in here. We have 12 volts coming to this battery here, and then we have our conductors, and we have a switch, and we have a motor which is going to be our consumer, and then we have these conductors on. So what I want to state outright is that from this battery, I think you can see the symbols, you can read the symbols of a battery. So this is the positive side, so which means this is our positive side. Our switch is on the positive side, and this is the negative side. Okay, this is the negative side. That's the negative side. Okay, and then so we have got the load, the switch, the battery, the conductors. What I don't have is a fuse. I'll try to get a fuse, because we need in every circuit. I'm repeating myself to those who know me well. In every circuit, but it's worth repeating, worth reminding you all. In every circuit, you need the source, which is the battery. You need the switch. You need a protective circuit, which is your fuse. You need the load, which is your consumer, and then you need conductors. This is a complete circuit. Once we close that switch, whatever the load it is, if it's a bulb, it will come on. If it's a motor, it will run. So like in this case, let's go. If I close here, you can tell, you can hear that this motor is running, and you can tell the speed of them. You can tell that it's going faster. You may not know what the speed is, but it is going fast. You can tell that. It's making a sound. Why? It's because I completed the circuit, right? So I will open here for now. So what I want to start with right away is an open circuit. I think an open circuit is the easy one to do. So that's what I want to start with. So my open circuit, hopefully this will work. You see that switch there? If I close the circuit, if I open, but maybe let me not use the switch as an open circuit. For this time, let me pull out a conductor. Let's assume we have a broken wire. Okay, let's assume we have a broken wire. But to help you here, our broken wire is on the positive side. So if I had a board here, I could draw something for you here. I don't know what I did with my board. My helper is not even near me here, so to help me. Anyway, we'll see to that. The open is on the ground side. Sorry, it's on the positive side, because our positive side starts right here, runs through the switch, and up here. From this side is a negative that runs up here. I repeat this because it is crucial. It is important to a technician to know which side is your ground and which side is your positive. That's why if we don't know, we are testing wires, we have to go and test the wires first and say, oh, this is the positive, this is the ground. It is important to ascertain that aspect first. Okay. And then we want to, also the other thing that I want to emphasize is that the importance of the Lord. The Lord is between, it is in between. It is sandwiched by your positive and your negative, and the Lord is in between. So you want to know, where does my power start and end? Where does my ground start and end? It is important to know that. Before I go to test anything, allow me to talk about those things, because that's where many of us, including myself, that's where electrics becomes a thorn. It becomes a problem. So, right, okay, let's do the simple things that we need to do when we're working, we are testing electric circuits. So the first thing, anybody who can tell me what is the first thing, if you want to type in the comment, what is the first thing that we do when we're working with an electric circuit? We have a fault and we want to test it. What do we check first? If anybody can quickly maybe type there so that I can see that I've got a live audience. Anybody, anyone waiting to see here? I haven't seen a chat come through. Right, anyway, what we do is when you're working with an electric circuit, the first thing that you do is to check your battery, the source. It is important to check that. I think you can see we have 11.965 volts, roughly. Well, we have we have got 12 volts roughly. Okay, so it's important to know what your battery is reading, because that will help you to see if we have got any voltage drops along the circuit. Don't just blindly just go straight and start hooking about and testing before you check your battery. The battery is the first thing that you need to check. Right. So now, maybe before I create let me put back the, I'll go again on the source. Okay. I want you to see, if I go on the source and close the switch, you can see that I still have near battery voltage. Okay, I still have near battery voltage. What causes 11.8 is the resistance in the motor. So when you come across the motor, you want to see that. You want to see that voltage. Okay, so now that I've established that the voltage that is in the battery, you're going to find it as well here on the motor across the load. That's where you're going to find that as long as everything is going fine. Yes, it's clear. Cliff, I see there, yes. And I see Mdu Shaga, and as well here Tinashes Tolere. Thank you very much, guys, for joining this live stream. I really appreciate you. So you can see that the voltage that is on the battery side, if we go across our load, negative and positive, we should get that. But what I want to say to you is that the purpose, this load, I don't care. It could be as small as a bulb. Excuse me. It might be as small as a bulb. See this bulb here? Okay, this is a consumer, right? So when you have, remember, maybe let me start with some of these statements. Let me say to you, voltage, the voltage that we read here on the battery, voltage does not flow in a circuit, but voltage is the pressure that drives current. What flows in every complete circuit is current. Voltage does not flow. Get that first. It is only the pressure that is applied to the electrons. So the movement of electrons is what we call electricity. So now we saw that the same voltage we will see here across the motor. What is the purpose of the motor? The purpose of the motor is to consume the 12 volts that is coming from the battery. It should be completely consumed by the load. When I'm saying load, my pronunciation might not sound right to somebody. It's L-O-A-D. Okay, it's an electrical load. Okay, so the purpose of every load is to consume voltage in a circuit. You cannot have a circuit that does not have a load and not have fire. It's immediately when the switch is closed. Once we remove that, if you will find that it will cause fire. Okay. So now I'm going to create my open circuit. You don't know about this on a car. Okay. You're just called, someone gets into the car, they turn the ignition switch on, nothing is happening. Let's say that is a headlight switch, the headlights are not turning on. Okay, so something is wrong here. We want to investigate. We don't know. I know on the board you can see what I've done here, but many times we don't know what is going on. Okay, so now we want to investigate. So we are going to assume, because what we're going to do maybe is to assume, is it a short? Is it an open? Is it high resistance? We don't know what it is. Okay, let's assume it is an open circuit. What are you doing when you are looking for an open circuit as a technician? Let me say this to you. You check the two sides, your power and your ground side. The side that is going to have voltage is the side that has got an open. Get me right here? Let me repeat myself. I said, you check both sides one at a time. If we check the ground side, that's why I said it first. It's important for you to know where your power starts and where it ends, where your ground starts and where it ends. So you go to the ground side and then you check for voltage. You are looking for voltage on the ground side. So the switch is on, and then you go on the ground side or on the positive side and look for voltage. The side that is going to have voltage is the side that you want to investigate for an open. Cliff is saying, so you mean load consumes voltage, but current is what turns the motor? Yes, current is what is driving that. Okay, current is what flows in the wire. Those electrons, maybe what I need to do, I need to come and maybe talk about the basic electrics. so that we start with an atom, we split an atom, we look at what an atom is comprised of. Okay, so yes, it is the voltage is just the pressure. So according to Ohm's law, Cliff, according to Ohm's law, when we increase voltage, current increases as well. When voltage is low, current is low as well, because voltage is what drives the current. So whenever voltage is down, you expect the component not to work as much as it should, not to work well, actually, let me put it that way, because there is not enough current, circulating in this circuit. That's why we can actually tap current. We can put in an ammeter. Okay, we can check for current from here, and you can actually check for maximum current, all the current that is flowing in. So if I had, maybe let me say, if I had parallels, you can check current that is going in one parallel line, another parallel line, So in this case, I just have a simple series circuit. Okay, we will talk about these things, God willing, and as long as we still have life. So let me see some of the questions. Let's see some of the questions here. Right, anybody? Okay. Right. Okay, I think I'll answer these questions as we go. So now, let's check the negative side. We said our negative is from here up to here. Can you see the voltage on the meter? Please shout out if you can see what the meter is reading, because I'm not sure if you can see that. Can you see what the meter is reading there, gents? I'm trying to have a setup. This is our first live stream, so there's bound to be mistakes. If you can forgive me for that. Can someone just confirm if they can see what the meter is reading in the comments? Correct. Yes. Thank you, Alphonse. Thank you, Cedro. Thank you. Yes, it's reading 0. Okay, it is reading 0. So we are on the negative side. We came negative and we are negative. Okay, so remember what we said. We said whenever we have an open in a circuit, the voltage will be found wherever that open is, the side that has got that open. So in this case, we have checked the ground. Let's go to the positive and see. So here on the positive side, look what we have. We have 11.966, which is our battery voltage. And we are finding that on the positive side. And let me explain why. Because last week, I think there were a few guys that maybe did not really get what I was saying. Last week, I said something concerning, voltage being found on the ground side, and I think it didn't augur well with some of my friends. But yes, so here's what is happening now, okay? Here's a positive, all right? And we said our ground ends here. But gentlemen, because now we have an open here, that ground is going to be found, so that ground now is going to travel to the other side. Now it's going to be found on the positive side. See now, the ground now is going to be found on the positive side because we no longer have a complete circuit. We have an open here. So that ground will run right up to here instead of ending here when things are operating normally. Okay? When things are operating normally, the ground should stay here. So those who were with me last week on Zoom, this is what I was talking about. Okay? Ground has gone through that motor. There's no longer resistance in this motor. This is just becoming one of the conduits. You know, there is no resistance to consume the voltage. Why? Because we have not a complete circuit. So I have proved to you that you will only find voltage on the side where your open is. So when you go positive to positive, 0, negative to negative, and then you find your battery voltage there. So straight away now, what you need to do now is to carry out a continuity test now. You are now going to go and carry out a continuity test and see where is this break. Okay, where is that break? Okay, you can carry. I think I've got an error here. Bear with me. I have an error. Oh dear. Just bear with me. My screen just went. I think I've lost connection on one of my big screens here. It's rock admin rules. Oh, I have my screen back. Sorry guys, I lost my screen here. Right, sorry, I apologize for that. I don't know what happened to my screen there. It was saying there's an error, but I managed to bring it back. Let me close that there. Right. Are we good to go? Sorry guys, apologize. Right, unmute. Right, okay. So now, let me say to you then, I was saying that when we come here, we can check for continuity. We come again here. We are going through, you know, the different stages of that wire that we are suspecting of an open. We are not suspecting anymore. We have confirmed that it has got an open. So now we just want to locate that code open. So if we continue, you know, going that, you can watch my meter, you know, you can watch my meter there. And then when we come here, if you notice, there you go. I have a reading 0. I have nothing here. Okay? I have nothing. Or else, I can actually do it differently. I can actually check for voltage. Okay? I can actually check for voltage. So if I come here, I have no voltage. I've moved from resistance. Come here, no voltage. If I come here, I have no voltage. I come here, I have no voltage, but if I come here, I have voltage. So which means my open is on the one previous. This is where my open is. Before, see this point where I got a reading, and here now I've got full voltage. So this side, no voltage, no voltage, no voltage, no voltage, and now all of a sudden I get a voltage. So I will investigate this point and this point. That's where my open is. And look now, I said this last week as well. Look, if I let me close that open, now that we've found it, we fix that open. Let's see what happens. I am going to close here. I am on the positive side. I'm checking the positive side with the switch open. Okay, you get 0 volts on this side. I got 0.06. You know, about roughly 600 millivolts. It's not too bad. Okay, but whenever we had an open, we had 12 volts in that position. But now we don't have 12 volts because now we have a complete circuit and we are on the positive. Positive to positive will always give us about 0.0 something. You know what I said last week when I was asking you guys, if we take probes and put them here and there, what do we get? And I was saying we get 0. That's exactly what I meant. You know, we get 0 because we are on the positive side. Okay, we are on the positive side. That's why we are getting 0.0 something. Okay, there's a little bit of, you know, of voltage that will trickle down there. On the positive side, you know, usually is 0.5, you know, or on the ground side 0.25 or 0.3. It's still acceptable. But once you start to get a volt, then you know that you've got high resistance somewhere. You might need to check your connections. But anyway, that's not what we were talking about. What I wanted to establish here today was that when you have an open in a circuit, it will be on the side where you find voltage. So that is established. Let's do it this way. Let's have an open on the ground side. Okay, let's have an open on the ground side. And then we can go and check. We can check the positive side for voltage. As you can see, we do not have any voltage on the positive side this time. Okay, and then we come and check the negative side, and then we have got all the voltage on the negative side. So I know there are other ways of doing these things. Okay, right. Dewey is asking a question here. He's saying, which direction does the current flow? That's a good question, that one. It is actually a good question. To answer your question, my brother, it depends on what you are talking about. If you're talking about the conventional flow of electricity, it's a law, by the way. The law states that electric current flows from the positive to the negative. That's the electric conventional law. But if you are talking about the electronic law states that current flows from the negative to the positive. And the reason why that is because electrons are negative in nature, It is the electrons that flow, it's not the holes. Because if you check in a circuit, you'll have holes, you'll have electrons. The electrons, the holes don't flow. What flows is the electrons. And the electrons are attracted by the holes that are on the positive side. Therefore, they move from the negative to the positive to complete a circuit. It's a big question, that one, do. That actually, science, you know about science. Science will, they'll always find a way, you know. It was big thing that all current flows only from positive to negative. But now they are saying, oh no, yes, electronic current flows from negative to positive. So I hope I've answered your question. Sorry, I had taken my eyes there off the ball, and I've just seen your question there. Yeah. So it depends. If I were you, I'm in an exam, do, and you know, like I would put those two. If the question is not specific, if it doesn't ask you of the electron flow, if it doesn't state that it's an electron flow, or if it doesn't state that it's a conventional flow. So if it doesn't state that, I would put both of them. I would state that the conventional flow states this, that current moves from positive to negative, whilst the electron flow states that current moves from negative to positive. And I'll leave it with the examiner, you know, to sort it out, you know. So you really want to check and see, you know, what is asked, because you can be right and still be wrong. Because if they ask you about the conventional flow of current and then you say it's negative to positive, that's wrong. That is going to be marked wrong and you not get it. So there you go. I hope I've answered you. Just send me a message there if maybe if I answered that one right. If you need me to elaborate on that, maybe, I don't know. I can get other guys that are here as well to, you know, to help me if I haven't answered that one right. But yes, that's what I know about the flow, the direction of flow of current. That's a good question. It is a good question. So we have established, therefore, now that the open is actually on the negative side, because that's where we are finding the voltage. So it's a matter of now going along that wire and then checking to see if you can find where the break is actually. And it takes, it doesn't take long actually when you get used to testing things this way to find an open circuit. It does not take long. Right. Are there any questions pertaining to the open circuit? Are there any questions, or, you know, people are happy? Is Mr. Zimi here? Is he? He was asking me for a link before we started live stream. Is Mr. Zimi here? I don't see him. Let me see. Just typing in the chat. Any questions about the open circuit? If not, then we can actually move on. Oh, yeah. Thank you, my brother. There is Mr. Mdu. He says, yes, he's answered. He appreciate that. Thank you very much. Appreciate you. Um, I really appreciate that. So, okay, I'll close that circuit then, and then. So now, uh, let's look at the effects of high resistance in a circuit. So according to Ohm's law, we say voltage, we say voltage is equal to current times resistance. That is Ohm's law. So when we want to find one of the two, current and resistance, we divide voltage by either. So now, if we increase resistance, so in this load here, is it possible to start checking continuity before checking for voltage? Yes, someone is given, Mr. Given. Yes, it is. It is very, very possible. It is very, very possible. Thanks for doing that. I was struggling to see. It is very, very, very possible, Mr. Givendale. You can just go and check continuity. But I'll tell you something. Continuity is not always the best way of testing circuits. Can anyone help me on that one? To you all that are on the live stream here, why is continuity not the best way to test circuits? Voltage drop is the best way, Mr. Given. Voltage drop is the best way of checking for resistance or for an open. You want the circuit to be live, because continuity, I've seen continuity really, really cause problems in my life as a technician, in the sense that you will find that in a wire, only maybe one strand is now left connecting, the whole wire. If you are going to check continuity, it will buzz. You'll hear your meter, it will go pee, and then you're happy. You move on, and that has deceived you. You see, watch out for continuity whenever you are doing it. Remember continuity as well. Remember I said to your question, yes, it's possible. But I just want to highlight, to show you how you should be careful of continuity. I'll come to you, Cliff, there. I see as well you have posted something. Continuity, Mr. Given, you only carry it out when the circuit is off. The circuit is not under load. And some of these troubles, electronic problems, they will show up when the circuit is under load. So if I say to you, right, okay, check this, let's check the motor. If we check it for resistance, we have to disconnect it. You cannot check for resistance on a live circuit. Why? Remember, your meter has got a 9-volt battery. So whenever we check resistance, we disconnect the component, and then using the 9-volt battery that is in the motor, in the meter, in your voltmeter or your multimeter, we send current around the circuit, okay, to make sure that it's complete. And so if then you check resistance on a live circuit, now you have got two batteries. You have got this 12 volt, and then you have got this 9-volt battery that is in here. something has got to give in. Your 9-volt battery will give in and you damage your meter. So when you're checking resistance, gentlemen, don't check resistance when a circuit is live. When you want to know the effect of resistance in a live circuit, you check for voltage drop. All right. Cliff saying, so continuity sometimes gives false troubleshooting result. Correct, 100%. Continuity does. It does give false readings sometimes. It will do that. It has got its place. It has got its place. But if you go down the lane of voltage drop, you can catch everything that is in that circuit, because now you are putting the circuit under pressure by running current through it. You have got voltage running current through that circuit. And now you're pressing it and you're putting it under pressure, and it will manifest itself. You're going to find that it is actually going to manifest if there are any issues there. Voltage you'll find that the voltage will drop. And then you can actually pinpoint that there's an issue, because otherwise you don't have voltage drop if there's no high resistance. If the resistance is high, continuity will still be okay. If the resistance is high, well, remember when you are left with one strand, that's very, very high resistance. Yeah, it will still buzz. It will still buzz and just give you a false impression. Am I alone in this? Has anybody come across that? In your, I want to believe that we have, gentlemen, come across that. We have actually come across that. Some of us. So let me see. Just want to greet some people, some of the people in here. I have got someone here by the name AEGEO. I can't pronounce it, forgive me, but we actually welcome you. And then we have got Alphonse Dube. Thank you, Mr. Dube. And then we've got Mdu Shaga. Thank you, my brother. We happen also to have the Mr. Apple's Gaming. So Cliff as well. Shout out to Cliff. And who else? Maybe I didn't see someone there. I think these are the ones that I can see at the moment, you know. So yes, really appreciate your participation, gentlemen. So I'm gonna just keep this to an hour, but let me introduce something here so that at least we can make the most of this time that we have, and then I can open for questions. So here we go. Maybe let's do the test first before we. So we said that if we come here, we have got battery voltage 9.92, and then if we come here across the motor, we have got 9.85. So, and our motor is working, our load is happy, it's smiling, our switch is working good. So now, let's add, we will add high resistance in this circuit. Let us add high resistance in this circuit. Let's see, yeah. We are going to add high resistance, and then what we want to do is we want to check here. Look at the voltage that we have now across the motor, and our motor is not working. The switch is open, I close the switch, and the motor is not working. And if I check across, I find that I have zero volts. Okay, so if I can then go on the ground side and then go on the positive side, I have my battery voltage. So now I can go and check my positive side for voltage. And you can see immediately when I came here, I still have battery voltage. Mind you, I'm on the negative side of the battery here. Okay, I started like that. So I'll investigate that side first. So if I go here, I still have my battery. If I come here, I still have my battery. If I come here, I have lost my battery. The same voltage that I'm getting across the load is what I have now. And immediately I know that my issue is between this point here and that point. Sometimes, you know, on a car we have connectors. You'll have this connector, that connector, until the wire gets to the component that is being driven. Okay, but we go through from the ECU, you'll find there's a connector here. So usually the connectors, they can be notorious sometimes, especially let me see. Oh, we cannot. Can you see now, Cliff? Can you see my meter? Cliff, can you see my meter there? Clear now? Okay. Right. So now I'm saying then that we have dropped voltage. But look, just here we were good. And to the next connector, we have an issue. So now we know where the problem is. We know where to check. We can now check that particular wire in this place. Okay. It might be long, it may be short. Depends, you know, with manufacturer. Depends on what you are working on. So now you know that this is where. But look at the effect of high resistance. Just shut down the whole system. Okay? It has shut down the whole system. So that's where that's how you test for your high resistance. Okay? The high resistance, it depends on how big the resistance is. If it is small resistance, you may find that that motor will work. Oh, can't read the meter. Can you see it there, delay? Can you see it now? Carmen, can you type in that if you can see? Delay is saying you can't see the meter. Can you see it, guys? Oh, Carmen is saying yes, we can see it. Okay, yeah, that's okay. I can see it now. Okay, so I've moved the delay. I hope you can see it now. Oh, that's fine. That's perfect. Thank you. So we are saying then that there is our problem between that point and that point. So now we have to open that loom. Okay, once you start with the wiring, get ready to open the loom. You know, get ready to be opening looms, because you will find that you will find that some of these problems, Thanksgiving, Takunda Koro. Thank you, my brother. Thank you. Nice to have you here. Tinomuvonga Rutsanya. It's all right. Thank you as well, my brother Tinomuvonga. Based on your demonstration, yes, continuity gives false troubleshootings stand to be corrected. No, you're right. You're right, Mdu. Continuity does cause us problems. Let's do it. When anything else can be done. I've done continuity, and you know what, and got away with it, especially when you have got an open in the motor. Sorry, not in the motor. In the component that you are checking, you have an open, complete open. Wires are broken. Okay. So you will find that in that case, you have when you have an open, it's an open. There's no reading. Your meter. By the way, technicians. By the way, let's do this while. Forgive me. My mind when I'm presenting, it tends to just go everywhere. Bring me back if I'm losing track here. I was thinking about checking for continuity there. When you check for continuity, sometimes you just find there's an open. You need to be able to read from your meter, your multimeter. Ladies and gentlemen, when you have an open, you will have, if you check your component for continuity, let's say you're checking an injector. Let's take a petrol injector, simple petrol injector, one wire from pin 1 to pin 2, just wound, through a coiled, right? And then it's the same wire. And then you find that when you check for continuity and you have got an open, you will have on your meter, it will read 1. Your meter will be showing the symbol 1. Then you know that that's infinity resistance, so you have an open. Or some of the meters will show OL. When you see your meter is showing OL, it means that's infinity as well. It's over limit. Some of the books would say it is over limit or OL, and it will show OL. Whenever you see OL, whenever you see 1, then you know that you have an open. But when you check the 2 pins and you see your meter going 0.000, and then it gives you maybe 1.3 or whatever, you know that is not an open. That circuit is actually complete. I thought I should just drop that one there. Maybe it might benefit somebody. Okay. So yes, that's where we are here. The nature of our resistance. Let me see if I can create another resistance. Bear with me. Let me see if I can create another. So I want to show you that resistances are different. My main screen is giving me problems here, gentlemen, but as long as you are happy on your side, my main screen is, I think it's my, let me see, one of my cables here. But anyway, I'll carry on. That's fine. So I was saying to you, it depends on how big the resistance is. Okay, some of the resistance will actually allow the motor to work. Yeah, my screen is stopped working there. Okay, that's all right. Okay, that's fine. So I'm talking to my engineer here. So now, if you me see if I can have another resistor there. Bear with me. See if I can have. We have resistance in the circuit, but the circuit is working. Okay? If we come here, we have battery voltage, check here. We have dropped from 11, we have dropped 2 point something volts. Don't take that lightly. Even though the circuit is working, do not take that lightly. Investigate and see what is causing that, because I want you to see the difference. Listen to this. Listen to this. Can you tell the difference in sound? That's a difference in sound. Let me bring the resistor back. The load is working, but it's not, we are not getting maximum utilization of the load. Because why? Now we have two resistors in parallel. Remember, every load in a circuit is a resistor. Every load that is in a circuit, that bulb is a resistor. It does have resistance. Okay? So, in that model, we have a coil of wire, and that is a resistor. So now we have additional resistance besides the engineered resistance. This resistance that is in the motor, it was engineered by the engineers. It was checked. It is suitable for this circuit. But now we have an additional one. The motor is working, but it's not doing the right job. It's not moving at its speed, but it is doing something. So once you start to check the two sides, you go in there, you come here, you have got your voltage, you come here, you have dropped voltage by 2. That's why I'm saying it is important to you, technician, to make sure that you check. You want to make sure that you check your battery voltage first. Please check your battery voltage first. That's the only way you can pick up these voltage drops. We have a voltage drop there from, oh, thank you very much. Thank you very much. I really appreciate Mr. Cedro. That's my first donation. Thank you very much. I really love that one. Yeah, this will go down history because that's my first donation. I really appreciate that. Thank you so much, Mr. Cedro. So here we go. Let's see, 11.93, 9.1. That's a big drop. You want to investigate that. Okay, that is a big drop. You want to investigate that and make sure that you know what is causing it, because it is going to affect, it has become an additional resistance, unnecessary resistance, unengineered resistance that we do not want, which is affecting what we are doing with this motor. If this was a light, it wouldn't be as bright as it should be. Okay? It wouldn't be as bright as it should be. This is the motor. The speed is not as high as we would want it to be. So something here is not going to work right. That's the impact of resistance in a circuit. It might totally, it might bring the circuit to ground, I mean to a halt, totally, depending on its side, on its size, sorry. Okay, so I can only talk about the impact, the effect of resistance when I've measured it and seen what it's doing. Especially when I close the circuit like this and see what is happening, you know, to the motor. Now I can say, oh, the motor is not running as fast as it should be. But you saw the first one, the motor did not even turn because voltage just went straight to. Can someone calculate? Can someone calculate? Wow. I don't have current. If I had a current clamp, I would have said calculate voltage, but we don't have current. So let me not, we can't, because we need current and resistance in order to calculate the voltage. I wanted to show you that the effect, the higher the resistance in a circuit, what is being affected is that the current is now less. And because of what? Because the voltage that drives it has dropped. The voltage that is the one that pushes the current in a circuit has dropped. So that's the reason why we are in this situation where the motor wasn't turning. All right? But we have seen here that, you know, that we can actually investigate and see what is causing there. You know, what the voltage drop is. We've dropped from 11 to about 9.2. So let's investigate this point where we are getting battery voltage, and that point when the battery voltage has become lower. All right, so that's the effect of resistance in a circuit. It depends on how big the resistance is. It can either shut down the whole circuit, or it can cause the circuit to work partially and not fully. So there you go. Any questions or any additional comments? If you have been in a situation, I would welcome people, you know, if you can tell us your story, if you have been in a situation like that where, you know, high resistance was causing you problems, because this causes headaches. It does cause headaches, you know, until it is investigated properly. So that's that fixed. So to conclude this live stream, maybe I'm going to rush this, I don't know, just for the sake of time. If we have a short, especially a short to ground, a short to ground will bring our live side to 0 volts. A short to ground will bring our live side to 0 volts. And because what a short does, a short can manifest itself in 2 ways. The short can manifest itself in 2 ways. Either inside that motor, where you have this coil, okay, you have 50,000 coils. There is a breakage inside in there, and then now you are only left with 25,000 coils. The other coils have been bypassed. Maybe because of a breakage in there, there's now only 25,000. So what that does, it will reduce the resistance in that motor. The resistance drops down, and that opens a floodgate for the current. Current just comes flying. And you will know if you have got a dead short. Your fuse will pop. Okay, the fuse is going to pop up. And then what you do, you get another fuse, or you just think, maybe get another fuse, put it in there, pops again. Right? Here, I know. I remember when I used to be, when I used to live in Africa, when I was in Zimbabwe, before I knew about electrics and stuff like that, and I would see technicians sometimes go and get a bigger fuse and put a bigger fuse. Yeah, it can work to a certain extent, but what you have done now, you'll find that the circuit will start overheating now, because now there's too much current flowing in that circuit. It will start overheating, and if that happens, you might cause a fire. Never you ever fit a bigger fuse. Current will forgive you if you fit a small fuse. A bigger fuse, you might cause a fire that can actually burn the customer's car to the ground. Do not do that. And I've seen other guys, sometimes they'll cut take a few strands from a wire and then join the other side of the fuse and this side of the fuse, and go. Yeah, right. That's okay. It's just for as an emergency, because it might cause you a lot of issues. I have seen this really causing fire, and you don't want that to happen to you. You do not want to have that happening to you, because it is not good. It is not good. So I say that's one way a short can manifest itself. It can be within the component itself. Okay. Cliff is typed something which means we might have a scenario whereby we condemn a component for not working while problems within the wire. Correct. Yeah, Cliff is right. He's saying, the way we had high resistance here, sometimes we miss it and then come and condemn the load itself, when the issue is in the wiring. Okay, so I'll come with ways, and show you how we can actually check if the problem is in the wires, or if the problem is in the component. We will do that. This is our first live stream, and I am really pleased to see people joining within a short time of notice. I'll do my best, next time to try and alert you on time, so that you have the stream, you have the link, for some time, before, so that I don't just shock you and say, hey, come within an hour with your live stream. And gentlemen, Cliff, you're right. I agree with you. Here, once encountered a problem on electric mirror switch. There is another one there. Someone had, a problem with the electric mirrors. I'm actually fixing one at the moment. I've got a Volvo that one folds in, the other one doesn't fold in. You can actually tell that the power is there. I think there's an issue. Seems to be high resistance. I think water went in. You hear the mirror just going crrr, crrr, crrr. It's trying to move, but something is stopping it. And I'm thinking it's just high resistance. Maybe it can just go away with spraying, WD-40 or any penetration oil, So that's something that I'm going to check as well. So yeah, yes, that's correct. So the other way a short can happen, you'll find that the load is fine, but maybe the wires are touching. Okay, we have a wire. Let me see, bear with me there. We have a wire that is now, it's now touching the positive side and the ground. Okay, it's now touching the positive side and the ground. Okay, if we close the motor is not going to run. Okay, the motor is not going to run if we close. And if we check, our voltage now across the battery has gone to 0.6. Hope you can see that. It's gone to 0.6. Okay, why? Because now we have a short to ground. We have bypassed the engineered resistance. Now current just flows. Remember, if you want to, one thing that you should remember with the electrons, they are very lazy. They take the path of least resistance. So once they come here, they don't want to go through the resistance in here. They bypass that and jump onto the ground side. Okay, and the whole, so here is what, let me give you an example. You could be working with a 5-volt reference. Yes, this is another thing that is difficult for technicians to diagnose. You could be working with a 5-volt reference, and one sensor on that 5-volt reference tree, the 5-volt reference tree could be having 5 or 6 sensors all connected to this one 5-volt reference. And you could be having another 5-volt reference that has got maybe 3, 4, or 7 sensors. So if one sensor is pulled to ground, it pulls the whole family of 5-volt reference. The whole family. If there are 5 sensors, all of them, they are not going to work. But it is your duty now to find out which one is not working. So what you do, you go to one of those sensors and then you connect to your meter. Just pick one, but don't pick a temperature sensor. I'll explain why at some stage. Do not pick a temperature sensor whenever you're doing this. Whenever you're investigating a 5-volt reference, do not pick a temperature sensor, whether it's a coolant temperature sensor, whether it's a what gearbox, oil sensor, or whatever temperature sensor, air temperature sensor, whatever. Do not use it. We'll come to that at some stage, not now. You just go to any other, it could be a pressure sensor that is using 5 volts. Go to it and then go and tap and check for voltage on the power side. Just go on the power side, check for voltage. It's giving you 0. Then now you need a manual. You need a manual to know how many sensors are connected to this 5 volt. And then the manual tells you 5 of them are. If 5 of them are, right, you go to the other 4, disconnect one by one, watch your meter. If you are going to, once you get to the one that is shorted to ground, the moment you disconnect like that, boom, your 5 volt comes straight on the meter. Then you know that's the devil. You deal with it. Okay? The moment you disconnect it like that, your short to ground is gone, 5 volts comes back again. You are good to go. You can only know when you have a manual. I know that this could be a big issue with some of our brothers and sisters. Manuals. Let's try and get manuals, because you'll be surprised what you find in there. What you'll be shown, it will show you what is connected inside the ECU. Yes, you have got one 5-volt reference coming out, but it's actually being sent to so many sensors. Okay, so once you have that knowledge, you just go in and pull out. If you pull out the one that has got an issue, bingo. The reason why I say don't use a temperature sensor is that, mind you, a temperature sensor uses 5 volt. But the moment you click it on, that voltage drops to 3 point something. Some of the cars, also 2.3 something or 2.5. Okay, so don't use that one. You want a sensor that, when disconnected, will give you 5 volts straight away. When connected, it will still give you 5 volts. Okay, But the temperature sensor by nature, when you connect it, drops. Why? It has got two resistors in series. Gentlemen, let me end here with this live stream. The moment you disconnect, your sensor will work. To me, son is saying that I came across this guy who said these modern machines no longer have a short to ground. How true is that? Whoa. Ooh. To me, son, I work on the modern machines. I don't know which machines he's talking about. I work on cars, on modern cars. Mercedes-Benz, BMWs, you name them. They still have a short to ground. They do. I think maybe he was trying to tell you something, maybe a particular circuit or whatever. I don't know, but as far as I know, I'm still dealing with short to ground even today. I am. Once it counted, I read that one from the family. I want to end the stream here, but I'm welcoming questions and comments. Let's just have maybe 10 minutes and let's discuss what we have learned here. And, you know, give me your comments and see maybe where you would want me to go next. You know, if you have got an area that you think, maybe I'm not good here, maybe something that I said that you didn't understand, clearly understood, that you want me to maybe elaborate on next time, let me have your comments on the stream. As I wait for your comments, maybe I'll continue to talk about a short to ground. I still find that on Dumisani. What machines are you working on, Dumisani? Oh, Mr. Gudo, thank you. I really appreciate you, Gudo. Is my young brother Tambaoga on here? Is he? Dumisani, I was just asking you a question there to say, what modern machines were you talking about in particular, say? Looking at the charts here. Anybody with any contribution, gentlemen, you are welcome. Are there any questions? Mr. Gudo, did I clarify things? Takunda, I'm well versed about this live streaming thing. Is it possible that you put this stream on your channel? Yes, this will be on the channel, Mr. Takunda. It will be on the channel. Straight away after this, it will be available on the channel. You can go over it over and over, you know. You can go over it, you know, at your own time, you know, and try. If you have any questions, what I'm going to do is, if you have got any questions, just post them on the on my YouTube channel there, or you can post them to Cliff. You can send them to Cliff as well, you know, on the chat with the engineers group there, and whichever way you want, you know. I'm trying now to be proactive with the channel. I did go away for some time, but I want to make sure now that we maintain the channel going, and so that, you know, we can teach each other, you know, a few things. But I'll be learning from you as well. If there's something that I said that you think maybe you know it differently, please send me a message on YouTube, a comment on YouTube, and then we can discuss that. So my question is about wiring diagram. Which site can we access wiring diagram? Because on Google some are not there. Mr. Given, which country are you living in, sir? Which part of the world do you live in? There is Mr. Cedro, I said that if you increase voltage, current is going to increase as well. If voltage drops, current drops as well. Okay? So where you have got high current, there is a chance that you also have high voltage. Or Mr. Given is in South Africa. Cliff, are you working, Mr. Given, do you work on small cars or on heavy trucks or plant machinery? Are you on trucks or machinery, heavy equipment? Thanks, Mr. Takunda. Thank you very much. I see your comment there, Mr. Takunda. You said not well versed. You'll be okay with time. You know, when we go through these things, you know, you'll be picking up a few things. You know, with time, I can tell you, you'll be good. You'll be good. Yeah. So the engineer there is saying, I'll make a post on YouTube based on this live stream. If you have any questions or queries, you can comment on there. So yeah, the engineer is gonna do that for us, gentlemen. He's gonna do that for us so that we have anything. Oh, you work on small cars. That's my field, Mr. Givendewa. Some of it, Google sometimes does give stuff. But I would say to you, maybe I'll give you my WhatsApp channel that you can send me a message if you need a wiring on concerning something, and then I can actually send you the wiring on WhatsApp. You know, if I'm available, I'll try and help that way, because I do have. There is Ndu Shakas given. Try Michelle or All Data for wiring diagrams, but it's a paid service. Correct? Yes. And I can tell you that, you know, that Michelle and All Data, I like them because they are very, very clear. You know, they even show you what is inside the ECU. Okay, but there's a subscription fee there, of course. But Cliff, I think Mr. Cedro there, he can tell you about what he did sometime. He went onto YouTube, not YouTube, Autodata, and he subscribed for £1, and then they gave him access. Was it for a day or for a week? I'm not quite sure. And then he went there and downloaded what he wanted, you know, within the time frame he was given. Downloaded what he wanted, and he had a few wiring diagrams there, you know. So yes, but yeah, subscribing on Mitchell and All Data, or even Autodata itself, you can subscribe onto those guys, and they will be able to give you a service. But you want to subscribe if it's going to pay you back. You don't want to subscribe if you're doing it for work. It is work that should actually subscribe on your behalf. But I know that some workplaces don't do that. I'm well aware of that. But what I would want to say to you, I'll put my WhatsApp number on the platform as well, so that if you can, contact me, I can help if I'm near the computer. I can, because I get that through my work, so I can. It's free of charge with me. I can actually help in that regard. Yes. Thank you very much for your comments, gentlemen. Really appreciate. Is there anything that we can tackle before we have about 3 minutes to come to an end? Anything that we can tackle there? Any questions that are burning? The other thing that I would want to say to the technicians, maybe before we go, is that when you buy a meter, if you buy a multimeter, gentlemen, please buy one that can measure at least 0.5 of a volt. At least 0.5 of a volt. I'll tell you why I'm saying that. My one, I bought this one years. I've had this thing for, I think it's almost 10 years now. Okay. And I'm still using the same battery. I haven't even changed the batteries. I bought this one from China. I bought it for about $200 and something. And it measures 0.25, a quarter of a volt. The reason why I'm saying this is that when you're diagnosing some of these sensors, whenever the ignition key is on, they give out a signal voltage of about 0.5. So if your meter only measures 1 volt, okay, if your meter starts from 1 volt, so you are going to miss that 0.5. It will not pick it up. It will say 0 volts when there is actually a signal that is coming from a sensor. So you have failed already. Whatever you are doing, you have started wrong there. So be careful what meter you use. Try not to buy the 10-pound, meters or 12-pound meters. Try and go and read the spec first and get the right meter. It will pull you out of the hole. It will help you with electronics. Most of the sensors, whenever the ignition key is on, they do give out a voltage of about 0.5. So watch out for that one. That's why I am saying be careful. All right. Hopefully that will help someone who was thinking of buying a meter. Right. Unless Mr. Dewa is saying thank you very much, sir, for sharing your WhatsApp number. Yeah, I'll definitely share that one with you. I'll appreciate your time as well here. How do you calculate or know the appropriate fuse to use in a given circuit? Well, you really don't need to go down the path of calculating what is needed and do, because if you notice, most of the manufacturers, they give us a legend that tells us what fuse goes in a particular place. So usually I just open the lid, or let me see, can I show this? Bear with me there. Maybe before we close, can I show this? I think if my engineer can come here and help me, I'll appreciate that. Let me see if I can project this here and show you what I'm talking about. Let's see if I can. to show the screen. Let me just pick that one there. Oh, wiring vehicle fitted with mic. That's all right. I want to project this. Let me see, where is my fuse? Where is my fuse? Here. Right. So. Yeah. No. The fuse one, yeah. So when you are on auto data, it shows you all that. You see, it's telling you there that's engine bay, footwell 1, footwell 2, footwell 3, load area, fast shear. So, if I go in here, right, and if I go like that, you can see if I highlight that fuse, it's actually telling me it's fuse number 14 and it's a 15 amp fuse. So usually I don't get to calculate, a fuse. I don't. I just go by this. And some of these cars, whenever they come, if you open the lid, the fuse cover, if you check underneath, you'll find that there is everything that you need. Okay. So as you can see here, that's what I go by. It will tell me it's a 5 amp, it's a 10 amp fuse, or it's a 40 amp fuse. So it's all given for you to. This is the system that I was saying there, Mr. Dewa, that we can go to the wiring diagrams. So if I go to technical, I can go to the one. Where is my wiring? Engine management, and then I can go to the wiring diagram, and so I can, so that's my ECU here. Okay, it's telling me that it has got, this ECU has got 3 plugs. There's A, okay, which has got 53, and then there's and that is black. Okay, SW stands for black, and then you have got B, which has got 53 pins, which is gray, and then you have got C, which has got 48, and it is brown. So I know straight away that, so when I'm looking for, let's say, an injector, I'm looking for injector, I want to diagnose an injector. So I know that it's pin C, which is the brown one. It's on plug C, which is the brown one. And I just go straight to the brown one and unplug that one, and then go to M3 and M4. I know that I can diagnose injector number 1 when I do that. So that's the information that I was saying to Mr. Given. I can actually maybe copy that and send it to him and share it with him. All right, gentlemen. I hope that was helpful. Takunda says, I joined late. Did you mind sharing your WhatsApp number again? Say, I'll share my WhatsApp, Takunda. I will share my WhatsApp. It will be on my WhatsApp number. Where's my WhatsApp phone? I don't have it at the moment. I will put it on the on our chats on YouTube there. Okay, I will put it on for you to. It will come, gentlemen. You'll see it. I'll let you know. I'll clearly mark it out as WhatsApp contact number for James, so that you don't get lost with that. I'm noticing that there are 20 people on the stream, but whenever I was just gonna close on 10 minutes ago, there were about 16 people. So which means there are 4 people that joined us just now. maybe they didn't get much, but I'll say, look, next time maybe you'll get more as we talk about these different subjects. It might not be me talking. I'm not going to be the only one using this live stream. There's Cliff. It could be Cliff. It could be, we use this live stream. This is my first time to use the live stream, but Cliff uses Zoom. Okay, he goes on Zoom. Where is it? Where is it? Is that it there? Right, so here is my, let's see, plus 4, 4, 7, 4, 4, 1, 2, 7, 5, 9, 6, 3. That's my app number. Ladies, gentlemen, that is my app number. So if, where possible, you know, I'll share what I have with you. If I don't have it, I'll let you know. Sometimes if you've got questions, you can contact me. It's just that my schedule at the moment is becoming really, really difficult because I'm working 5 days a week, where I actually used to work maybe about 4 days a week. One day I'm at home. So, but I'll do my best. I will always do my best. The problem with my WhatsApp, it stays at home. I don't carry my WhatsApp phone, so it's only when I come from work that I see. That's when I see these things. So you may find that I might take a little bit of time to respond because my job. I realized that when my phone was on my WhatsApp was on my work phone, you know, it would ping when I was at work, and I found that it was causing me problems at work, so I leave it at home. Okay. Tumisani says the person was saying, since this ECU is grounded, if we have a short to ground, we will cook the ECU. What is he saying? Right. What I can say to me is that the modern ECUs, they are protected, but I have seen them go. But they are supposed to be protected from shots. Okay, they are supposed to be protected from shots. Yes, that much I know, but it doesn't mean that we don't have a shot at all with the sensors and other things, but it's the ECU itself. It's a protection that the manufacturers try to put so that, you know, when there's a shot, you know, the ECU at least is safe. Yes, when it comes to that now, I'll agree with you. They are well protected, but I've seen sometimes they go still, you know, but I agree with you. Yes, they are. Now I get where your question is. Okay, but you still get sensors, you know, having a short to ground. Very possible, because once a power wire, you know, touches the body or the chassis, and maybe it's been rubbing and then it loses insulation and then it touches the body and the chassis, yeah, that's it, short to ground straight away. Okay, but yes, ECUs can be protected, but do not bank on that, because I've seen youngsters fry ECUs there. Like I know one of my boys took a jump pack, and then he forgot to turn it to 12 volts, and it was on 24 volts. ECU gone. Okay, and this was a Mercedes Benz. So yeah, these things do happen sometimes to me. But I get your question, my brother. Right. It's very difficult to part, isn't it? Very difficult to part. Maybe next time I'll try and make this a little bit longer than today. But yeah, I really appreciate everyone who joined us Keep an eye. If it's not a Zoom link that you're going to get next time, it will be a live stream, from this platform. Sometimes it will be me, sometimes it will be other people. So just like we do on Zoom, it could be Cliff, it could be Tambaoga, it could be me, it could be other people. And we still welcome people who think they have something to share with the team. We don't mind you sharing that with us. But look, let me say to all of you, thank you very much. Until we meet next time. Bye-bye.